Alright, let's finish then the chapter today.
I built this as helpful.
Alright, I'm gonna make these smaller so I have more room.
You guys can.
Oh. Alright, I'm gonna make sure that you have a few equations here that I don't know if I gave you. I just want to make sure. Do you have this equation? No.
Cold, 10% cold. What did you just say? 10% actually cold.
No, I think I gave it to you, but I don't want to assume.
You didn't have the VI times change in T part of it.
We don't have that one.
Yeah, you
Write
gave
it
us
in.
one.
Here's another. This one I'm pretty sure you don't have.
Wait.
This is a very. This equation I don't know if you'll need to use more than maybe once, but.
For the first one, you already gave us one of them, but it just didn't have the VIY times change in T.
This part?
Yeah. You
That would be assuming that your VI is gone.
Oh, okay.
It's zero.
We only need the
Interesting stuff.
That's actually.
Kramer, you said we get multiple note cards, right?
Yeah, if you.
Because I'm writing kind of big.
That's fine.
If someone not in this class, I'm taking this class, you want to put that in
I think that would
under what?
Man, doing this kind of stuff made me feel real smart though. I will say.
Right here.
Yeah, just.
No, I'm not. Man, isn't he the advanced freshman saw this? They'd be like, I didn't think he'd like needlessly.
Put it on.
How is that a easy definition of the word?
You know what? You need this thing that he needs.
Yeah, that's true. It doesn't work. No, take.
Alright, we ready? So now, here's the difference between what we did on Friday and what we're doing today. We are shooting at an angle. I'll try not to draw pictures, and I'll just assume we're on the ground, and we're shooting a flare right out of the ground. How's that? It's a board.
It's
a flare board.
Oh, wait, just make him catapult.
Okay? And we know that this angle is what?
What was that? The grass.
So it says flyer at an angle of 35 degrees to the ground. That means it's from the ground.
Yeah, like up from the ground.
That's kind of like 45 degrees.
Like,
When it says to the ground, I mean, there's no, I mean,
Just say from the ground.
It's
like
same
what it
thing.
means.
To the ground, from the ground.
right? Now we know something. We know the initial velocity, don't we?
Yeah.
Zero. No, it's 250.
Oh. Now notice, in the horizontal problems, my VI we could assume was Vx. Yeah. Is this shot at an angle, is all of this going to be x? No, some of it will be a y component, some of it will be an x component. This is where it makes it difficult.
That
In
VI is
horizontal projectile problems, the VI is always the Vx. Because you're shooting straight horizontal, so it's all x.
Well, VXI is always VI.
We're doing it right now. I said it's gonna have, it's got, this is not all horizontal. It's got a vertical component and a horizontal. So, we're going to have to get a Vx and get a Vy.
Wait, you have the triangle right there.
Just because the Vx and the Vy is going to be the same throughout the whole process. Of it.
Slopes on that. Wait, wouldn't the VX split up?
No? Why would it slow down?
That's like, you go forward and start going.
The only thing that's going to be changing is your Y. Your horizontal stuff's going to keep going horizontally without effect, unless there was wind, but we're assuming no wind.
But on your VX.
Like it.
After I shoot the object, what's the only thing acting on it?
Air.
Gravity. Remember, air is not in the question here.
Not air, but even still, wouldn't it like, in my head, if you're moving like down and that way, you're moving more down that way.
Why?
Because you're moving
Depends on
down.
the angle. Well, your head is thinking that correctly.
Well, so okay, so like if it was like the drawing would be more flat if it was real.
But a 35-degree angle would probably be more like that.
Okay.
But I just drew it to make it big so you can see it.
I'm sorry.
Like if it were like if anything below 45-degree angle is going to have more X than Y. Anything above 45-degree angle is going to have more Y than X. That makes sense, right?
I got that money for me.
Halfway between a 90. So if I'm doing a steeper angle, it's going to go further. It's going to have more change in X than it has change in Y. But if I go straight up, it's going to be more like that, have more change in Y than change in X. Okay? So let's do this. That's pretty much all the information they gave us, didn't they?
Do we have 9.81 meters per second squared?
Yeah. So let's write it down. We know VI. Now I didn't put VIX or VIY, I just had VI.
Yeah.
And we know acceleration is negative 9.81. And they really didn't give us anything else, did they?
No.
Oh, it just wants the maximum height.
Okay?
Maximum.
Now listen, anytime you're doing a projectile that has an angle, Jim, question.
What is the difference between maximum altitude and maximum height? Oh, should ask for both. Oh,
Okay? So, listen now. Steven, turn around, Max. We don't have time to waste today. We really don't. This problem will take us probably 15 minutes. That will probably take us 15. And the last will probably take us 15. I won't get to it. Okay? So, anytime you have a projectile shot at an angle, even if you don't need to do it, get in the habit of doing it. This is what I want you to do. Anytime you have an angle, break it into an X and Y. Even if you don't need it, do it so you have it just in case. Now, do we have any issues taking a hypotenuse and turning it into an X and Y?
No.
Sine and cosine. Let's do it. Go ahead.
Wait, why do you overlook the whole thing?
What?
Why are you using 250? That's the whole.
That's the initial velocity at that angle. So technically this is Vx, Vix, and this is Viy. I should probably put this next here. Vix.
Going up less fast than going sideways.
So,
So I'm taking my initial velocity and breaking it up into how much of my initial was x and how much of my initial was y.
well, why can you use that as your hypotenuse?
Because I know that I'm shooting at a specific angle like that, so there's a triangle there.
Oh, so you're just implying that it's only going until the number would change.
Yeah, that's fine.
Well, the x would never change, but the y would, yes. We're talking right as it's shooting out. Yep. Okay. What is x?
205.
4.8.
Whatever.
And y?
1
Okay, so we want two things in this problem. How long does it take for the flare to reach its maximum altitude? So, AKA time at this point.
Did you make the Pythagorean theorem?
Because it needs time.
How long does it take to get there?
That looks like a lot.
And we cannot use Pythagorean theorem to find this because it is not a straight hypotenuse to get to that. It's going to be a parabola because it's in free fall.
Yeah, just.
Now, the second thing we need is what?
Maximum height. The maximum height.
Okay, so we want
Change it to
the change in y here. So we want the time it takes to get to the maximum height and what the maximum height is. All right. Here is the easiest way to figure out the time at that peak. Okay? We have a problem here that we know this, right? And we know this, right? And we don't know this, yeah? Okay? So we really have two unknown variables here.
Wait, you don't tell me.
well, 3 if you count
It's not
the
anyone
square.
second.
Okay, but t and t are the same
Yeah,
variables,
yeah,
okay? So I have really two unknown variables here. If I could somehow find what the change in y is, I can figure out change in t.
Yeah, but
So here's what we're going to do. There is a point in this motion where we do know the change in y. Does anybody know where in this motion where we would know what the change in y is? The final. What is it? Zero.
wouldn't it be the same from the beginning though?
Yeah, but yeah.
I'm sorry, I'll stop.
Okay, so we know right here my change in y equals 0. Because I started at 0, I ended at 0, my change is 0. Okay? Now, the reason why that's important is we know this is a perfect parabola because we're assuming free fall with no air resistance. Which means if I know the time it took to get here, I could just take half of that to get to the peak. Everybody see that?
Yes, we do that.
Okay? So what we're going to do is use this equation where we're going to set change in y as what?
Zero.
I like that.
VIY we said was 143.4. We don't know change in t, that's what we're solving for.
So are you actually gonna have change in DQ? I said, will you eventually have change in DQ?
No.
If you put, okay.
One of the t's will cancel out. You'll see in a second.
Divide by 1.
Okay? So now we just have to solve for this. It's not super easy. Let me think here. What would be the best way to do this?
We're not use that one.
No, I don't think the 1/2, you know. But you can prove me wrong, I guess.
Wait, Kramer, what equation do you use? That one?
This is, I use it y equals VIY.
Change y, because isn't that y final?
Change in y is the difference between the initial and the final.
It's a space.
Changes.
Oh, 'cause it's 0 and 0.
Yeah, start at 0. If it would have been anywhere else, it would have been, my change would have been not 0, but at the end it is. Okay? So let's subtract this portion over here. And the reason why I'm going to do that is because then I'll have a negative and a negative, which will eventually cancel out. I'm subtracting it over to see why it's making it negative.
And that's why.
So if you look at this, do you see how one of the t's is going to cancel out?
Yeah.
Anybody, everybody see this? Are you leaving?
No, I'm just moving, because your back's always there. So.
Oh, sorry.
No, it's fine.
So this will go bye-bye. This will change to 1. Okay, then if I divide by both of these, do you see how my negatives will cancel?
Yeah.
Anybody not? Guesses that no you don't, or? So it should be divided by 1/2, 9.81. You can either take half of that, or I know that half is the same as multiplying by 2. need to do it step by step. However you need to do that. Okay.
Wait, what? Would it not still be negative 9.81?
There, when this came to negative over here, so the two
yeah.
negatives would cancel out when you do.
How did you get rid of the t squared? Divided by the t.
When this brought over here, there was a t over here and two t's over here. One cancels out.
Okay.
So it's 29.2.
Is that what you get? 29.2 approximately.
Second.
But it wouldn't be.
But that wouldn't be your answer.
No.
You'd have to divide by 2.
Okay, so this would be the time it would take to get from here all the way to here. Okay? It wanted to know how long would it take to get to the peak. Well, that would just be half of that. So you would just take this and divide it by 2.
14.6.
14.62.
15 actually.
If you're doing that.
15.
So 14.6 seconds. Your final answer for that should be shown in significant digits, so it would be 15.
And then you still have change in what?
So then you plug in
Okay. Now, your answer will be 15 due to sig figs. But I would still use this number when you're solving for the second part of it. Okay? So, now that we know the time it took to get to the peak, couldn't we just use the same equation, but put in the time that would be at the peak to find what the peak's height would be?
Probably. That seems okay.
So like get rid of the 0.
Yeah, instead of, so we want to, anywhere in here, not at the end, I do have a change in y. Okay? Well, remember, there's a horizontal time period here. Okay, once I find the time, I know I'm at the peak with what this time is here. So if I plug in that time into this equation, it'll give me where I am on from a change in y standpoint, which we said was at the what? The peak. Okay? So we're using the same equation, but using the time it would take to get to the peak to find what the peak's height is. So change in y equals what? 143.4.
So it's 1.0.
6 is our time I'm plugging in. Plus 1/2, negative 9.1.
Yeah.
14.6 squared. I'm going to use my unsig fig answer when I'm plugging in to do another problem.
So,
What did you get?
I got 1.0 times 10 to the third. Yeah.
I got
it's the same answer, it's
1,048.
just a 6 figs. Yeah, it's showing that's the same answer, just without 6 figs.
Oh, gotcha. I was too smart.
What do we get?
1.0 times 10 to the third meters. Or 1,048 meters.
Yep. Question so far? You don't get that, Autumn?
I can't tell if I got it or not.
You can't tell.
No.
1,000?
1,048.
Yeah.
Well,
it's
that
not-
is the right number, not in the correct sig figs then. Okay, moving on. Move on to next problem, which is number 1 in your homework. We're not going to get to number 2 in your homework, but number 2 is really difficult, so I'll give you extra credit if you get it right.
Oh, that's low.
I doubt anybody will get it, but
I can't.
I just said that just because I know some of you will try really hard.
Yeah, that's all I should know.
Now, if you get it, you may not share it with somebody else. I want to see your work. You're going to turn it into me. Do it
Sure.
together.
Come on.
Study hall 7th hour if we do it together.
Fine. If you do it as a group, that is fine. But if you like share it with somebody after you've done it, then that's not okay. And I'm going to use the honor system. And I'll make it 2 points of extra credit. How about that? No, 2 full points of extra credit.
If you do number 2, or all
If you
of
get it right.
really,
On the test.
Lauren, Jesse, and Steve.
The test.
Okay, next problem. This one's a little bit more difficult. Well, I don't know. I wouldn't call it more difficult. Okay, it's just got kind of a goofy setup. So if you're struggling with the whole picture thing, this one might be a little harder. Okay, in a scene in an action movie, a stuntman jumps from the top of one building to the top of another building 4.0 meters away. After a running start, he leaps at a velocity of 5.0 meters per second with an angle. What did I say that wrong? 15 degrees with respect to the flat roof. Will he make it to the other roof? Or will he die?
Die.
So is it a yes or no answer?
Yeah, but you need to prove it with mathematics.
Yes.
Yeah, they're like, yeah, I'm not gonna give you any math, but you're gonna make it. So just jump.
Just
Okay. What?
Wait, which one is extra credit?
The number 2 on your homework.
Oh.
This is number 1 on your homework. We're doing a homework problem for you. So let's draw a picture. We've got some building.
I changed my answer to yes.
Okay, and we got some building here. And he's jumping off one building to another. Now notice, he's jumping right off the corner at an angle, correct?
Yeah.
So we know that he's going initially at 5.0 meters per second. And we know this angle here with respect to the roof, right? The flat roof is 15. I didn't write it much.
I don't know if it's gonna make it.
Okay?
I know.
How far is the x component of the jump?
4 meters.
Well, that's what it has.
That is.
Yeah.
So the change in x is 4 meters.
Wait, this is the hardest chapter.
There's chapters that are closed. Yeah, this is not a Okay? And then it tells us something. That this roof is a certain amount lower.
2.5 meters.
So we'll say from, I'm hard to draw that. Yep. So from here to there would be my change in y. Now notice, positive or negative?
Negative.
So negative 2.5 meters. Okay. So we want to know if he jumps up, is he going to get enough horizontally to make it on the roof? Or is he not and come splatting into the side of the roof, the house?
Follow your change in x.
Okay? We know what the change in x is. We want to see what his y is at a 4 meter change in x.
Oh, I guess that makes sense.
Okay? What?
That's his initial velocity.
Yeah.
Okay. So, I'm not sure we need it, but what we're going to do is we're going to resolve these two velocities. Just get in the habit of doing it when you're doing a projectile motion. So first off, my VI we said was 5. Let's take that VI and convert it into a VIX and a VIY. Sine and cosine.
1.3, 4. X is 5. The y is 1.3. Yeah. X is 4.
1.3 was the y.
I don't think he's going to do it. 4.8.
It's likely that dude was slightly.
Remember, he has 2.5 meters of wiggle room.
Oh, we do.
Like, he has, essentially what he has to do is he has to cover 4 meters of x before he falls 2.5 meters.
So he's getting higher than 2.5 to that.
Yeah. Initially, yeah. Essentially, off the beginning, he's actually got even more of a wiggle room, yes.
Trying to flex it so it's yes, that means even more now.
It's yes.
Okay? Now, just like in that last problem, we identified a point in the curve, and we identified what that time was, and we can figure out the x or the y position of it. So here's what I mean. I want to know the time when he is has cleared 4 meters horizontally. Yes.
So wait, can we plug in?
Why would you wanna know time?
Because I have to use the time to find the change in y.
Wouldn't you just like plug in, couldn't you just plug in like the change in y, like,
This one?
no, like older versions, one of the older versions.
Depends on
Like
what.
change in x equals root 2y over a times bx. Can you use that one?
Horizontal.
That one's a horizontal component. It's just horizontal. All of it's horizontal. No, there's no y component. If I was shooting a golf ball straight off of it, yes, you could use that. But I'm shooting at an angle, so there's a y component to it. It's got to read. Because what if that were happening, it would just be dropping immediately. Here it's going up, has to slow down, and then drops. Does that make sense?
So then can we plug in the 2.5?
Sorry, say that again.
Can we plug in the negative 2.5 with the change y equation at the top? Or-
Yeah, but we won't know. I suppose you could do that, find the time, and then find the change in x. You probably could do that. I think. I don't know, but you probably could. What I would do is use this. I don't know the equation on top of my head. Where's my notes?
Oh, wait a second.
There's all the score of the change in x.
Oh wait, if that was my answer, which I thought that was.
Is that an equation? I feel like this isn't an equation.
That'd be awkward as well.
That's an equation, right? Or is that not an
No,
equation?
wait.
Yeah.
I mean, that's just the same as velocity, so yes.
Yeah, that's an
Literally
equation.
just velocity.
Wait.
No, it's not, because
That's
velocity
just-
assumes
that's
both.
just this equation.
Velocity average.
Oh, so it's a change in x, just,
Displacement.
yeah, okay. So in your note card, it's this.
That's not the same as velocity.
Because, well, it is if you're just talking about x, sure. Yeah. Okay? That was, I gave it to you Friday.
Yeah. No.
Well, it's the horizontal component, but we need it. We want to know, what essentially I want to know is, at what time have I cleared 4 meters? Okay? So if I take and plug in, okay, I want to solve for time here. Do I know Vx?
Yeah.
What is it?
4.8.
Why couldn't we use this equation on the last problem?
4.5. That's the
We didn't know the
It's
change in
VIX
x.
is 5. VX is
No.
5. Is that VX 5? It's VI.
Yeah, we would use it.
You don't need stickers until you're done with
And it would be that anyway.
VI is VX.
No.
No, that's not.
No, that's just straight. We're not shooting straight horizontal. We use this for straight horizontal, but it's more difficult when it's vertical. When you have a vertical component to it. It's still in the previous problems it was all x. Here we're using it just to find the x component of a much bigger picture. Okay, now what I'm doing here by putting 4 meters in is I'm figuring out at what time do I get a horizontal scale of 4 meters.
And if it's negative, it means no.
No, we're not done. That's not going to be the answer once we get this. Okay? What do we get for our time?
0.83 seconds.
0.83. So we know that's the amount of time it would take for me to scale 4 meters horizontally. Well, let's figure out at that time how much we fell.
We fell.
Using this.
And if it's further than 2.5, then
You didn't make it.
Okay.
Yep. Negative 2.5, but yes.
Kramer, how can you have 2 different variables?
What do you mean?
Meters and meters per second.
Because the meters cancel out, giving you with seconds, which is what time
Oh
is.
my buns, yes, okay.
Okay, so what we're going to do here is solve for change in y by plugging in where we know we'd have to be horizontally from a time standpoint. We know VIY, right?
Sorry.
Oh my gosh, is that? Hey,
So what, you wanted him to die on?
you guys are weird.
all right, you should get a negative number, which that makes sense. what is your answer for changing y?
Negative 2.3.
Oh, yeah, 3.
Alright, so the question is, did he make it or not?
Yes.
Yes.
So essentially, if I were to draw a picture of his motion,
It's all going like backflip.
is he would have went up in the air and he would be, by the time he scaled it 4 meters, he would be of only negative 2.3, so is he going to make it? Yes.
Is there a way to solve this using changing x?
Now I see trips. Now, what if it said when he scaled 4 meters, he dropped 3 meters?
He's dead.
He'd be like, bam.
But you know, it's like Mission Impossible when he has the sticky web, so he just grabs it.
Sure. Okay. So, I realize these problems take a little bit of thinking. The thing that you gotta think about is knowing from a time standpoint, you can figure out where you are in that motion if you find a specific time. Okay? Now, number 2. You do not have to do it if you don't want to, but it is an extra credit opportunity. And the only hint I will give you is you'll have to do quite a bit of substitution.
Maximum height. You're finding the big top edge.
Let's go. Earth and soup.
Steven, what's that after?
Oh, I
They broke up.
5.
After they're married and they go. Brad Pitt. Have you seen the video of Brad Pitt like trying to jump off the building and hit the stuff? Trying to do it. No, that's Tom Cruise.
Oh, yeah, Tom Cruise.
I have not seen that.
Yeah, the new Mission Impossible, they had to stop filming because he broke his foot.
What? No, it's seriously so funny.
Did you know that Tom Cruise is only like 5'7"?
Yeah.
Short.
Yeah, tell me. I want to start starting like cars. Oh my gosh, I want to hear lightning and forward.
Oh, you're using 4.8. You're using 4.8. You're using the Y component, or the X component, not the Y component.
Oh. Okay.
Like, I'm pretty sure you plugged it into your calculator, right? Like,
Calculator's right.
what?
What are you guys doing? Come on, trying to steal the plans. The Death Star.
You saw it, didn't you, Steven? You haven't seen the pictures yet? Yes, you have.
The what? The what?
Ethan's drawing.
No, I haven't. Won't let me see.
You gotta look at it.
Stevie, okay.
Show it to you now. You just have problems on it. We all got a bunch of matches back here.
Let me see.
We wanted to call they're just standing there. They kind of got farms up here. He's the real potato. No. It's a red carpet.
I went home and told my mom that.
You tell him Mr. Kramer's an awful teacher, I don't like him.
I like these photos. Like,
Cold in it.
yeah, wait.
I like how you guys are like getting what married. Ethan's like.
You're watching National Boy, bruh.
Curly, I showed Stevie. He's okay with this.
I never saw
I mean.